On August 15, 1977, in Delaware, Ohio, humanity was passively scanning the Sagittarius constellation for a whisper in the dark. This is a diagram of the Big Ear Observatory. Unlike standard movable dishes, it relied on a stationary, flat reflector tilted toward the sky. Because the telescope was fixed, it relied on the Earth's rotation to sweep across the starfield. This mechanical constraint meant any specific point in the sky was visible for exactly 72 seconds. Inside the empty control room, an IBM 1130 computer tirelessly processed the incoming data, diligently printing out the ambient background noise of the cosmos. Sometime later, volunteer Jerry Ehman was scouring through those printouts when he stumbled across an event with a massive spike in the signal-to-noise ratio, logged as the sequence 6EQUJ5. Instinctively, Ehman circled the sequence with his red pen and scribbled a single note in the margin: "Wow." The equipment had functioned perfectly, capturing an intense, narrow-band radio wave. Yet, because that solitary 72-second transmission was never conclusively detected again, it created a decades-long scientific vacuum. To evaluate this anomaly today, we use an observational balance sheet, weighing 4 undeniable empirical facts against 4 frustrating blind spots. This chart shows the peak intensity of the WOW signal. It was 30 times higher than the ambient background noise. The probability of a random statistical glitch producing this spike is 1 in 10 to the power of 196. This frequency spectrum shows the signal exactly at 1420 MHz, matching the emission line of hydrogen, the universe's most abundant atom. The cosmos naturally quiets down here, making 1420 a Schelling point, a low-noise channel where an advanced civilization might logically communicate. The third pillar is its bandwidth. The signal was incredibly narrow, limited to less than 7 parts per million. We simply do not know of any natural cosmic source in the entire universe that is capable of producing a radio signature this incredibly tight. Finally, this graph displays the signal's intensity mapping into a perfect bell curve, exactly matching the telescope's 72-second rotational sweep. This perfectly continuous profile rules out fast-moving space debris or low-Earth satellites. Together, these 4 empirical pillars systematically eliminate standard astronomical phenomena and human-made interference. But we have to turn to the other side of the ledger. There are 4 massive blind spots in the historical data that prevent a definitive conclusion. First, the 1977 technology could not detect AM or FM modulation. If there was a deliberate message embedded within that radio wave, it is completely lost to time. This shows the telescope's wide field of view, spanning thousands of stars and leaving the origin ambiguous. Then, the Horn mystery. Big Ear's 2 receivers swept the same sky 3 minutes apart. The signal registered in one, but vanished before the second passed. And the ultimate scientific frustration. Despite decades of active monitoring, the signal has never been detected a second time. These 4 shadows leave researchers in an agonizing deadlock. We possess a textbook candidate for an artificial signal, but we lack the necessary repetition to prove it. This forces a rigorous question. Does a lack of repetition automatically prove the 1977 event was just terrestrial interference? Over the years, modern observatories have pursued the anomaly, spending a combined 184 hours staring closely at the exact same patch of sky. Data scientists built a digital emulator, testing thousands of random alien transmission schedules directly against the historical observation data. This heat map shows that for a random schedule, detecting the signal once across 184 hours has a 1.8% probability, a 2.4 sigma event. Science requires a 3 sigma threshold to reject hypotheses. To mathematically rule it out, astronomers need 1,500 more observation hours. Under Occam's razor, the signal survives the statistical gauntlet, remaining a compelling anomaly waiting for us to listen again. So what exactly produced the WOW signal?